What would you like for breakfast, Johnny?
Muffins!
That's right.
At Cunningham Muffins, we know that muffins make the best breakfast. So why not try all of our exciting new flavors? Raspberry, cranberry, apples, cinnamon, pecan, pumpkin, nut, date nut, lemon poppy seed muffin, banana, orange, peach, strawberry, blueberry, boysenberry, almond, choco chip, carrot, gooseberry, pumpernickel, fish, paperclip, ink, bird, shampoo, Star Wars muffin, bullfrog, crickets, cigarette, Israeli-Palestinian conflict muffins, bits of glass muffin. Ow! Asbestos. I'm baking muffins as best as I can. Ah! Monkey. Al Jarreau muffin. Elephant. Pencil. Newspaper. Fire! Imaginary muffin. Cartoon muffin. Blood.
What muffin would you like for breakfast, Johnny? I lost my appetite.
You'll eat a muffin. You'll eat it and like it!
Are you not entertained? Are you not entertained? Is this not why you are here?
And now for something completely different.
What would you like to learn about in physics class today, Donnie? Forces! That's right! We know that forces are a push or a pull, or the ability to do work. So let's look at the exciting 4 flavors of forces. Gravitational!
3, 2, 1, see ya!
Electromagnetic! Strong nuclear force! Weak nuclear force!
This place was abandoned overnight. They had no time to take anything. Factories, schools, stores, apartments, everything.
There is Pripyat, home to the workers and families of Chernobyl. Reactor number 4, where the disaster happened.
Is it safe?
I have Geiger counter to let us know if the radiation levels are high.
I think I lost my appetite for forces. Oh, you'll learn it. You'll learn it, Donnie. And take off your hat and hood. You know the school rules. Okay. Alright, definitely can't talk like that anymore. Let's define the 4 forces. First force, gravitational. It basically says that all masses are attracted to other masses. Everything is essentially attracted to everything. So contrary to popular belief, you and I are all attractive. No. Next one up is electromagnetic. Electromagnetic holds atoms together, causes lights to come on, causes lights to be spread through the room, and everything you touch, feel, think is a series of electronic impulses. Next up is strong nuclear force. That one holds nucleuses together in atoms, and it creates atomic bombs and also atomic energy. And weak nuclear is the last one, and that allows for radioactive atoms to decay, so you have things like half-life. Next up is Newtonian dynamics, or Newton's laws of motion. So let's talk about Newton's laws of motion. Newton has 3 of them. The first law of motion is that an object at rest stays at rest. It's really not that exciting. The other thing that Newton's first law of motion says is that an object in motion stays in motion. That's what I'm doing right now. I got the cruise control set, I'm going 65, and unless some other force like a barrier in front of me or hitting the brakes or hitting the accelerator and speeding up acts, then I'm just going to stay at 65 the whole time. Now, Newton's second law. Newton's second law basically says F equals ma, which means that force is proportional to mass times acceleration. If you move some of the stuff around, you get A is equal to F over m. And that means that acceleration is directly proportional to F, so as force goes up, acceleration goes up, but indirectly proportional to mass. So as mass goes up, acceleration goes down. That should make sense because it's harder to accelerate something heavy, more massive. The last of Newton's laws of motion is that every action has an equal and opposite reaction. So, when I push down the hood, I push it down, that's an action, and the reaction is the hood with the pneumatic lift pushing back towards my hand. When I close the trunk, I have to push because it's pushing back because of the pneumatic lift. And finally, when I push the door, same thing. Action.
Wally.